You wouldn't merge your pull request without running your test suite, but right now, most of you are deploying agents with zero automated checks. Your agent coded a tool wrong yesterday and nobody caught it until a user complained. The reasoning quality dropped after a prompt tweak and you had no way to measure the difference. Today, we are fixing that. We are building an automated regression suite using Pytest LangSmith datasets and LangGraph so you can catch broken tool calls and degraded outputs before they ever reach production. Let's get into it. The reason most developers skip agent testing is that traditional testing patterns don't translate well. In a normal application, you give a function an input and you assert on a specific output. But agents are non-deterministic. The same input can produce different tool call sequences, different phrasings, and different reasoning chains. On top of that, every step in the agent loop is potential failure point. The model might pick the wrong tool, pass malformed arguments, or synthesize a final answer that ignores the tool's response entirely. So we need a testing approach that accounts for this variability while still catching real regressions. The approach we are taking is a dataset-driven regression testing. The idea is straightforward. You curate a set of representative inputs and expected outputs inside LangSmith, then you write Pytest tests that run your agent against every example in the dataset and evaluate the results with custom scoring functions. This means you are not asserting on exact strict matches, but you are checking structural properties like whether the correct tool was called, whether required fields are present in the arguments, and whether the final answer contains the information you expect. Each time you change a prompt, swap a model, or update a tool schema, you rerun this suite and immediately see what broke. Here is how the pieces fit together. LangSmith acts as your test case storage. It holds datasets where each example has an input query and a reference output describing what the agent should do. Pytest is your test runner, and inside each test function you call LangSmith's evaluate function, which takes your agent, your dataset, and a list of evaluator functions. The evaluators are where your actual assertions live. These are plain Python functions that receive the agent's output and the reference examples and then return a score. Your LangGraph agent sits at the bottom doing what it normally does: routing queries, executing tools, and synthesizing responses. The key thing is that none of this requires modifying your agent code. You're testing the agent as a black box from the outside. We are going to build 3 types of evaluators, and each one catches a different class of regression. The tool call evaluator checks whether the agent selected the correct tool for a given query. This catches prompt regressions where the model stops routing properly. The schema evaluator validates that the tool call arguments match your expected structure, so you will know immediately if a prompt change causes the model to start omitting required fields or passing wrong types. And the answer evaluator checks the final response for the expected content, which catches cases where the tool was called correctly but the model failed to incorporate the results into its answer. Together, these 3 layers give you solid coverage without requiring exact output matching. Now that you understand the architecture, let's build it. We'll set up a LangGraph agent with a couple of tools, create a LangSmith dataset with test cases, write our 3 evaluators, and wire everything together with Pytest. By the end, you'll have a test command you can plug directly into your CI pipeline. Okay, let's start coding. Let's open the terminal and create the needed directories. Those will be agent testing, which will be our project, and 3 subfolders: agent, evaluators, and tests. Let's move inside of the project folder. Next, we create a clean Python virtual environment, and we also activate it. After that, we install our required dependencies. Those will be LangChain Core, LangGraph, LangSmith, Pytest, and Python.env. Next, we need to create the empty initialization files for the Python modules. After that, we create the specific Python and environment files. Before we write any code, we need to configure our environment variables. Let's open the .env file. And we'll need the following. You'll need your OpenAI API key for the agent's LLM and your LangSmith API key for the evaluation platform. The LangSmith tracing variable enables trace logging, which means every agent run during testing gets recorded in LangSmith so you can debug failures visually. Make sure you have a LangSmith account set up. The free tier is sufficient for what we are building today. Now let's define the tools our agent will use inside graph.py. I'm creating 2 simple tools to keep the focus on testing rather than tool complexity: a weather lookup and a unit converter. Notice that we are using the tool decorator from LangChain core, and each tool has a clear docstring. These docstrings are critical because they are what the LLM reads when deciding which tool to call. If your docstring is vague, the model will route incorrectly, and our evaluators will catch that. The weather tool takes a city name and returns a hard-coded response, and the unit converter handles basic metric to imperial conversions. In a real project, these would call external APIs, but hard-coded responses actually make testing more predictable, which is exactly what we want. Okay, now we will need a few more imports. And now with our tools defined and the new imports added, let's wire up the LangGraph agent. We are using create React agent, which gives us a standard React loop out of the box. The model reasons about the query, decides whether to call a tool, executes it, and then synthesizes a final response. We are binding both tools, so the model, and wrapping the whole thing in a function called runAgent that takes a raw input string and returns the final message content. This wrapper function is important because LangSmith evaluate function expects a callable with a specific signature. It passes a dictionary with an input key, and your function returns the output. The key detail here is the invoke call. We pass the input as a human message, and we pull the final response from the last message in the return state. This gives us a clean string output that our evaluators can work with. Now we need to create one more new file inside the tests folder. Let's call it create dataset.py. Here we are going to put the test data. We are going to create a LangSmith dataset programmatically so it's reproducible and version controlled. Each example in the dataset has an input query and a reference output that describes the expected behavior. Notice that the reference outputs aren't exact strings, they are structured descriptions of what should happen. For the weather queries, the reference says which tool should be called and what city should be passed. For the conversion query, it specifies the tool name and the expected argument structure. This is intentional. Our evaluators will parse these references to check structural properties, not exact matches. I'm wrapping this in a script. You run once to see the dataset, and LangSmith will deduplicate if you run it again. Now let's run the script in order to create the example data. When you're inside the tests folder, type python create dataset.py and run it. When it's done running, you should see an output that says that dataset with 4 examples was created. Now let's go inside the checks.py file. This is the core of the whole system, the evaluator functions. Each evaluator is a plain Python function that receives a run object and an example object from LangSmith. The run contains everything that happened during the agent execution, including the full message history, and the example contains our reference data. The tool call evaluator digs into the message history to find any tool call messages, extract the tool name, and checks whether it matches the expected tool from our dataset. It returns a dictionary with a key and a score. 1 means pass, 0 means fail. The argument evaluator goes a step further and checks that every expected argument key is present in the actual tool call arguments, and the answer evaluator is the simplest one. It just checks whether the final output string contains the expected substring. Notice that each evaluator handles the case where no tool calls were found by returning a score of 0, rather than raising an exception. This is important because you want your test suite to report failures cleanly, not crash halfway through. Now it's time to connect everything in a single Pytest test function. We import our agent runner, our 3 evaluators, and the evaluate function from LangSmith. Inside the test, we call evaluate and pass it our runAgent function. The dataset name is a string and the list of evaluator functions. The evaluate function handles all the orchestration. It fetches each example from the dataset, runs your agent against it, passes the results to each evaluator, and collects the scores. We store the results object and then assert that every evaluator scored a 1 across all examples. The results dot to pandas call gives us a data frame we can inspect if something fails, and the assertion logic iterates over each score column to check that the minimum value is 1, meaning every single example passed. If even one example fails one evaluator, the entire test fails, which is exactly the behavior you want in a CI gate. Now let's run the tests. We use Pytest with verbose output so we can see exactly which test passed or failed. If everything is set up correctly, you should see 1 test collected and 1 test passed. Let's execute it. Fantastic, our test is passing. Let's now move to LangSmith and see a detailed breakdown of the test. Now this is what the test looks like in LangSmith. You can see the 4 different scenarios. Each one scored perfectly. Let's have a look at the first one. Here we want to see that the tool used is convert units. Let's check the trace. And yes, the actual tool call is the convert units. It also needs to be called with value 100. Let's now check the tool call and see, yes, it's being called with value 100. Here on the right you can see more additional details like latency, total tokens consumed, and calls. Let's recap what we built. We created a dataset-driven regression suite that tests our AI agent without requiring exact output matching. We wrote 3 evaluator functions, one that checks tool selection, one that validates argument structure, and one that verifies the final answer content. And each one catches a different class of regression. The entire thing runs with a single Pytest command, which means you can drop it into any CI pipeline today. For next steps, I would recommend looking into LLM as a judge evaluators for cases where you need semantic similarity checking rather than substring matching. LangSmith supports these out of the box. You should also explore the LangSmith dashboard to track your evaluation scores over time so you can spot gradual degradation across deployments. If this was helpful, subscribe to the channel. I'm building more content on agent reliability and production deployment patterns. I'll see you in the next one.